Okay, welcome back, advanced calculators. Let's take a look at how to evaluate definite integrals. This lesson is a mashup of the lessons that have preceded. So a lot of the ideas that we're going to look at are things we've been looking at, but through a slightly different lens now that U substitution is a thing. Speaking of, let's get that started right away. Let's find the integral from 0 to 1 of x squared times x cubed minus 1 to the 4th dx. Let's find this integral. Now, I know what you're thinking. You're thinking this is a U substitution, and it's a U substitution because that thing right there has its derivative right here, sort of. And I agree with you. We know what U is, and we know what du is. And we think to ourselves, we don't have 3x squared dx, we have x squared dx, and so that's 1/3 of du. I agree. So this is the integral of x cubed minus 1 is u, x squared dx is 1/3 du. Now, what we've had to do in previous lessons, we've had to pause on these limits of integration. We do the antiderivative, we substitute back in what u was, and then we can use the 0 and the 1 from before. But what if we did a complete change of variable? What if we got rid of everything that smelled like X and replaced it with something that smelled like U, right? Like, what if we decided that the 0 and the 1, those are X limits, what do they become in the U world? Well, if X is 0, then U is -1. And if X is 1, then U is 0. Now we've done a complete change of variable. We've gotten rid of every X-related thing. And whatever the answer to this question is the same as the answer to our original question. So let's do it. Let's use the fundamental theorem. Antiderivative of u to the 4th, substitute, substitute, and subtract the answers. Substituting 0, that's 1/5 times 0. Substituting -1, that's 1/5 times -1. Well, what does this become? That's 1/3 times 1/5 is 1/15. Done. I will show one more. Let's find the integral from 1 to 3 of x times the square root of 3x squared minus 2 dx. Now, again, I know what you're thinking. You're thinking this is obviously a u substitution, and we know this to be true because the derivative is pretty much hanging out right there, right? But we don't have 6x dx, we have 1x dx, and that's 1/6 of du. Now, what we would have done in times past is we would have said the square root of u, right? And then x dx is 1/6 du, the 1/6 can come out. In times past, we would have done the antiderivative, substituted back in what u was, and then done the fundamental theorem with the 1 and the 3. But we don't have to do that. We can decide that when x is 1, u is also 1. And when x is 3, u is 27 minus 2, 25. So now we have completely replaced the original problem with an integral that has the same answer. fundamental theorem says we take an antiderivative. Antiderivative of u to the 1/2, raise the power by 1, divide by that new power. Substitute, substitute, and subtract. How is this going to work? Well, the 25 is going to go in here. And when the 25 goes in here, we take a square root and cube the answer. The square root is 5, cube the answer is 125. Then we substitute the 1, take a square root, cube the answer, and we get 1/6 of 2/3 of 124, whatever that is. Well, let's see. 3 doesn't go in there, so it's 124/9. Okay? One more thing. Find the average value of y equals 4 minus x squared on the interval from 0 to 3. The average value. Now, average value is interesting because I know when people find averages, here's 4 minus x squared, right, on the interval we're talking about. When we think about averages, we think about adding everything up and dividing by how many there are. But average value, that's adding up all of these infinitely many y values and dividing by infinity. That seems like that's not going to work. So here's what we do instead. We say that the average value is the integral from 0 to 3 of 4 minus x squared divided by the length of the interval. It's the integral divided by the length of the interval. What does this do? Well, this part is an area, and this part is a width. So what the integral does is it basically trades out our region for a rectangle whose area is known. And then we divide that by the width, and it gives us a height. And that height is the average height of the function on the interval. So let's do this. Fundamental theorem says we take an antiderivative, substitute, substitute, and subtract the answers. We substitute the 3, that's 12 minus 27/3 is 9. Then we substitute the 0 and divide by 3. And it's not a lot of work to see that the average value on the interval is 1. Does that make sense? Here's 1. Well, maybe it does make sense. Maybe it does make sense that if we take the average of all those y values, the average would be 1. That feels like it makes sense. This is a thing that you have to know how to do, and I will look forward to talking about it with you when we gather. What does this lesson do that is so important? Well, it combines everything we've been learning about substitution, everything we've been learning about antiderivatives, everything we've been learning about the fundamental theorem, and it forces us to do that in new contexts. Looking forward to seeing you in class. Hope you enjoyed these 9 minutes and 30 seconds.